Hey everyone, myself Bhavya Goyal, a student at IIT Gandhinagar. I welcome you at CodeChef and let's have a look at this question. So yeah, today's question is high score, the easy version. In this question, we're given two arrays A and B, each of length n and m respectively. And in this version, it is given to us that n will always be equal to m. Now our score is initially equal to 0 and we can perform the following operation any number of times as long as both the arrays A and B are non-empty. So we can select any integer x from A and an integer y from B such that they are not equal. And we can remove one occurrence of x from A and one occurrence of y from B and add x plus y to our score. So let's say we have 1, 2, 3, 4, 4, 2, 1, 3. So we can choose, let's say this is our array A and this is our array B. So we can choose, let's say 1 and 4 and add 1 plus 4 to our answer and remove them from these arrays. Then let's say we choose 3 and 2 and add 3 and 2 to our answer and remove them from the array. Then we can choose 2 plus 1 and remove them from the array. And we can choose them and remove them also from the array. And this is the total final score which we'll get. Now we need to find the maximum possible score that we can obtain by applying the operation as many times as we want. Now in the constraints, we are given that n will be equal to n, n and m will be in between 1 and 2 into 10 raised to the power 5. A of I comma B of I would be positive integers in between 1 and 10 raised to the power 9. And the sum of n comma m over all the test cases would not exceed 2 into 10 raised to the power 5. Now let's look at the constraints once. So in the first input, we are given 777. So they are all sevens. So it's not at all possible to pair any of them. So the answer is 0. In the second input, we can pair this 9 and this 7. We can pair this 7 and this 9, and we can pair this 7 and this 9. So we can pair all of them with each other. So the total sum would be the total sum of all of them, which would be 9 plus 9 plus 9 plus 7 plus 7 plus 7, which would be 48. In the third, we are given 7779. So the best we can do is pair this 9 and this 7. And the total sum would be 16, which is our answer. Now let us see the solution for this. So first of all, let us intuitively think about it. So intuitively, if let us say we're given any array, we can just pair this and this, this and this, this and this, this and this, this and this. And like in general, we should be able to pair everything unless the count of any element is too high, right? So we're not quantifying anything here, we're just intuitively understanding that if unless the count of any particular element is very high, we can always pair up every element with every other element, right? So let's create two cases. So now the first case is what if the count of every element is less than or equal to n? So let's say we have five elements and the count of one is five and these are some other elements. So we can pair them up like this, right? And such a construction is always possible. So what you do is just get the element which has the maximum frequency and start pairing this with this and like every other element with the element which has the highest frequency. So start pairing this 2 with 1, 3 with 1, 4 with 1, 5 with 1 and 6 with 1. And it should always be possible, right? Now what if let us say the count is like something like this? We can still pair everything up with everything else, right? So just pair all of them with them and these with this, and it should still always be possible, right? So I'm not mathematically proving anything over here. You can easily prove that using inductions, but I hope it intuitively makes very much sense that if the count of every element is less than or equal to n, we can just pair everything up. And our answer in this case would be the total sum of both the arrays, right? Now, what if the count of any particular element is greater than n? So first of all, notice that if that is the case, then at most one such element can exist. There cannot be more than one element, obviously, right? Because that would mean that the total count is equal to or greater than or equal to 2 times n, right? Which is not possible, right? Now let us say we have something like this. We have 1, 1, 1, 1, 1, 1, 2, 3, 4, 5. Right. So the best we can do is pair every non-highest frequency element with the element which has the highest frequency. So we'll pair this 2 with this one, this 4 with this one, this 5 with this one, and this 3 with this one, and that is the best we can do, right? And there would be some ones or some highest frequency element, like some frequencies or some occurrences of the highest frequency element, which would not be added, right? And what would be the count of that? So that would be the total elements, that is 2 times n minus the count of the highest frequency element, which is 6 in our case. So this is the number of elements which do not have the highest frequency, right? So in our case, it is equal to 4. 4 times 2. So these are the 4 elements, and these will be paired up with some of these ones. So 4 times 2 would be the number of pairs we'll get, right? So this is the, so we'll get 8 pairs, and 2n minus this 8 would be the number of elements which would not be paired up with anything, right? So these ones won't be paired up, and how many such ones exist? That would be 2n minus 8, that is 2, right? So this is how you can just calculate it. So for the answer, how can we calculate it? It would be nothing but the total sum minus the count, where the count is the count of ones or the count of elements that cannot be paired up, times the element itself. So in our case, it would be the total sum minus 2 times 1, right? And that's pretty much the whole solution. You can implement it in nlog and using maps to track a count of frequency. And yeah, that's it. Now let's move to the solution in C++ first. So yeah, we'll first of all take in the input of t for and run a loop for each test case. Then for each test case, we'll take in the input of n and m. We'll take in the input of the array a and b. We'll increase the frequency of a of I and increase the frequency of b of I. And inside our total sum, we'll add a of I and b of I. Now we'll check if the frequency of any element is greater than n, and if it is, this is the elements which we can take. So that would be 2 times n minus the frequency of that element into 2. So these are the number of elements which are everything except the this particular I, and we're multiplying it with 2 because we can pair those element with the current element, that is the element with the highest frequency, and the elements will be left with which we cannot include in our sum would be 2 times n minus the elements which we can take, and in the sum we'll reduce it by I dot f minus the elements which we cannot take, and we'll just print it. And if there exists no element whose count is greater than n, then we'll just simply print our total sum. So yeah, the time complexity is n log n because we're using maps. And yeah, that's it. Now let's see the solution in Python. So we'll run a loop for each test case, and for each test case, we'll take in the input of n, m, a, and t. We'll create a frequency dictionary to store the count of each element, and total sum to store the total sum of the both the arrays. We'll store the frequency of each element in A. We'll calculate it, and we'll calculate the total sum of A. We'll also calculate the total sum of B and calculate the frequency of each element in the array B. Now we'll check if the count of any element is greater than n, and if it is, we'll just subtract the pairs which we cannot take times this key, which is this particular element, and we'll print that total sum. And if there does not exist any element whose count is greater than n, we'll just print the total sum. And yeah, that's pretty much the whole solution. Again, the time complexity is n log n because of this frequency. And yeah, that's pretty much the whole solution. I hope it answers. Thanks. Bye.